An object that has been placed into orbit in space on purpose is known as a satellite or artificial satellite. Most spacecraft, with the exception of passive satellites, contain a means of generating electricity for the technology they carry, such as solar panels or radioisotope thermoelectric generators, RTGs. The majority of satellites also feature transponders, which are a type of ground station communication system. The most common satellites, small CubeSats, use a standardized bus to reduce costs and labor. Satellites of a similar type can cooperate with one another to form constellations. Satellites are made to be as light and durable as feasible due to the high expense of space launch. Numerous transponders, each having a bandwidth of tens of megahertz, are carried by the majority of communication satellites, which are radio relay stations in orbit. Satellites are launched into orbit from the surface by vehicles that are high enough to prevent orbital decay caused by the atmosphere. The orbit of the satellite can then be changed or maintained using propulsion, typically using chemical or ion thrusters. In 2018, the majority of satellites orbiting the Earth are in geostationary orbit, also known as low Earth orbit, where the spacecraft remain stationary in the sky. Because they can survey the entire planet with comparable lighting, some imaging satellites selected a sun-synchronous orbit. The risk of collision is growing as there are more satellites and space junk around the planet. Several bodies at once or a small number of satellites circle other bodies, like the Moon, Mars, and the Sun, 2 for a halo orbit, 3 for a lysogous orbit. Earth observation satellites collect data for mapping, reconnaissance, and other purposes such as weather, ocean, and forest monitoring. Space telescopes use the nearly perfect vacuum of space to view objects across the whole electromagnetic spectrum. Communication satellites can transmit information to far-off locations because they can see a big section of the Earth at once. Satellite navigation systems like GPS make use of the satellite's signal delay and the predictability of their orbits. Space stations are essentially crewed satellites, while space probes are spacecraft built for robotic space exploration beyond Earth. On October 4, 1957, the Soviet Union launched Sputnik 1, the first man-made satellite, into Earth's orbit. The White House declared on July 29, 1955, that by the spring of 1958, the United States intended to launch satellites as part of the events scheduled for the International Geophysical Year, 1957 to 1958. The project was dubbed Project Vanguard. The Soviet Union declared on July 31 that it would send a satellite into orbit before the end of 1957. Sputnik 1, the first man-made satellite, was launched by the Soviet Union on October 4, 1957, as part of the Sputnik program, with Sergei Korolev serving as the program's primary designer. Through monitoring the shift in its orbit, Sputnik 1 supplied information on the distribution of radio signals in the ionosphere and assisted in determining the density of high atmospheric layers. The unexpected news of Sputnik 1's accomplishment led to the Sputnik crisis in the US and the start of the Cold War's so-called space race. Canada built the third satellite that was sent into orbit, however it was launched from an American spaceport aboard an American rocket. The same is true for Australia, which used a donated American Redstone rocket, American support personnel, and a combined launch facility with the United Kingdom to launch its first satellite. On December 15, 1964, an Italian launch team trained by NASA launched the nation's first satellite, San Marco 1, from Wallops Island in Virginia, using a U.S. Scout rocket. 17 similar events saw the launch of nearly all subsequent first-generation national satellites using foreign rockets. The companies developing the constellation started to propose routine planned deorbiting of the older satellites that reach end of life as a part of the regulatory process of obtaining a launch license after the late 2010s, and particularly after the advent and operational fielding of large satellite internet constellations, where on-orbit active satellites more than doubled over a period of 5 years. The International Space Station is the largest man-made satellite to date. The majority of satellites include reaction wheels to manage their three axes of rotation or attitude, in addition to chemical or ion propulsion to change or maintain their orbit. Satellites that are close to Earth are most impacted by changes in the Earth's magnetic field, gravitational field, and radiation pressure. Satellites that are farther away are more impacted by the gravitational fields of other bodies, such as the Moon and Sunday. Satellites in orbit won't be able to connect with base stations on Earth without orbit and orientation control. While a few use radioisotope thermoelectric generators in deep orbit where sunlight is scarce, the majority of satellites rely on solar power to generate electricity. Slip rings, which may swivel so that the solar panels are perpendicular to the sun and produce the most electricity, are used to secure the solar panels to the satellite. Due to sunlight being obstructed within the launch vehicle and at night, all spacecraft equipped with solar panels also need batteries. Lithium-ion batteries and, earlier, nickel-hydrogen batteries are the most popular forms of batteries for satellites. Remote sensing is a technique used by Earth observation satellites to monitor and scan the planet. While some are positioned in geostationary orbits for continuous coverage, the majority of Earth observation satellites are deployed in low Earth orbit for high data resolution. To have constant lighting and get a full view of the Earth, certain satellites are put in sun-synchronous orbits. The satellites may have a standard camera, radar, LiDAR, photometer, or atmospheric instrumentation, depending on their roles. The most common applications for Earth observation satellite data are in archaeology, mapping, environmental monitoring, meteorology, and reconnaissance. There are more than 950 Earth observation satellites as of 2021, the majority of which are operated by Planet Labs. Clouds, city lights, fires, pollution effects, auroras, sand and dust storms, snow cover, ice mapping, borders of ocean currents, energy fluxes, etc. are all things that weather satellites keep an eye on. Changes in the Earth's flora, atmospheric trace gas content, sea status, ocean color, and ice fields can all be found with environmental monitoring satellites. Droughts can be tracked by tracking vegetation changes through time and comparing the current state of the vegetation to its long-term average. Analyzing tropospheric NO2 and SO2 data allows for the monitoring of anthropogenic emissions. A communications satellite is a man-made spacecraft that uses a transponder to relay and amplify radio telecommunication signals. It establishes a channel of communication between a source transmitter and a receiver situated at various points on Earth. Television, telephone, radio, internet, and military applications all use communication satellites. There are 2,224 communications satellites in Earth orbit as of January 1, 2021. The majority of communication satellites are in geostationary orbit, which is 22,300 miles, 35,900 kilometers above the equator. As a result, the satellite appears stationary at the same point in the sky, allowing ground stations to point their satellite dish antennas there permanently without having to move them to track the satellite. The Earth's curvature interferes with the high-frequency radio waves used for telecommunications networks since they travel along a direct line of sight. Communication satellites are used to transport signals around the curved surface of the Earth, enabling communication between distant geographic locations. Satellites for communication use a variety of radio and microwave frequencies. International organizations have rules governing the frequency ranges or bands specific organizations are permitted to utilize in order to prevent signal interference. The likelihood of signal interference is reduced by this band selection. Satellites that employ radio time signals to help mobile receivers on the ground pinpoint their precise location are known as navigational satellites. Satellite navigation systems can measure location with real-time accuracy of a few meters thanks to ever-improving electronics and the relatively clear line of sight between satellites and receivers on the ground. While issues like radio and light pollution are getting worse, there has been no advancement in national or international control. Space debris puts satellites and other spacecraft in danger while in or crossing geocentric orbits and has the potential to cause the Kessler syndrome, which would make future human space exploration all but impossible. Because satellite transmissions have a weak received signal, terrestrial transmitters can easily jam them. Such jamming is restricted to the region covered by the transmitter's coverage. Although satellite phone and television transmissions have also been jammed, GPS satellites are a possible target for jamming. Additionally, it is quite simple to send a carrier radio signal to a geostationary satellite and obstruct it from being used for its transponder's intended purposes. In commercial satellite orbit, it is frequent for Earth stations to transmit at the incorrect time or on the incorrect frequency, dual illuminating the transponder and making the frequency inoperable. In order to efficiently manage the transponder space, satellite operators now have advanced monitoring that allows them to identify the origin of each carrier. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.